All right, welcome to the very last lesson of Math 65. We're going to talk today about quadratics, and we call this quadratic extension because this is just getting us ready really for a lot of the concepts you're going to learn in Math 95 as well. First thing you'll do probably in Math 95, well, I shouldn't guarantee that. Actually, you're going to do radicals. But then after that, you'll revisit quadratics. Right now, the only way we know how to solve a quadratic is by what? How have we been solving quadratics so far? We've been factoring, exactly, okay? So we always have to set that equal to 0. So let's look at this polynomial. This is, by the way, the same thing as y equals x squared minus 2x minus 8. What is the degree of the polynomial? Second degree. And how do we come up with that? Because why? X squared. So everything that's x squared is what we call a quadratic, and it's a second degree polynomial. Okay, we're going to complete the table below, finding 5 points on the graph for f of x equals x squared minus 2x minus 8. Then use these points to graph the function. So they're giving us a table of values here, and literally this is the very first thing you learned with graphing lines, correct? You could plug these numbers in. F of 0 equals 0 squared minus 2 times 0 minus 8. So what does that equal? When all is said and done? Negative 8. So that ordered pair is 0, negative 8. Where does 0, negative 8 live on the graph? It's going to, the ordered pair for this is 0, negative 8. 0, negative 8 is the same thing like, oh, when we were graphing a line, it's the y-intercept. So down here, I plot it, 0, negative 8, I label it, okay? This point, anytime x is 0, we call this point the y-intercept. How are we going to find, when x is negative 3, how do we find y? Negative 3 minus 8. So really, really important, and a common misconception here is that people will not square that negative. So you have to make sure when you plug it in to put it in parentheses, you get 9 plus 6 minus 8. What does that equal to? Is that right? 7? Yeah, 15 minus 8 is 7. So this ordered pair is negative 3, 7. So we want to graph that. We're going to go over to x equals negative 3, up to y equals 7. Negative 3 is 7. Here we go. Okay, now what happens when we plug in 3? F of 3 equals 3 squared minus 2 times 3 minus 8. So we get 9, this time minus 6 minus 8, which is what? Negative 5. So we have the ordered pair 3, 5. I'm just going to put them here. 0, negative 8. Okay. 3, 5. We go over to 3, up to 5. And this is looking like a really strange shape, isn't it? Am I doing this math right? Yes, okay, I am. Oh, negative 5. No wonder it looks so funny. That's not it. Why not negative 5? Because I made a mistake. That's why. Okay, 3, go over to 3, down to negative 5. That looks better. Okay, this point right here, 3, negative 5. And by the way, when I put the ordered pair next to it, that's labeling. Does it say to plot and label? Well, often it does, especially on your exams it says that. So I'm modeling that behavior. Okay, now let's plug in 2. F of 2 equals 2 squared minus 2 times 2 minus 8. 4 minus 4 minus 8. So what's that ordered pair? Oh, 2, negative 8. So I go over to 2, down to negative 8. And I drew over where that point is supposed to go. Okay, and now 1. Let's plug in 1. F of 1 is 1 squared minus 2 times 1 minus 8, which equals 1 minus 2 minus 8, which is negative 9. We have 1, negative 9. Thanks for being so mathy. And I will change colors so you can see. This is another special point right here. And do you know how I know what is this point called? This one, 1, negative 9. It's the vertex, because you see that these 2 points are symmetrical. Okay, and if I connect this other point right here, it has a symmetrical point that's actually also 2 points away. So right here, this vertex is the lowest point on my parabola. Okay, this dotted line is what we call axis of symmetry, which means that for every point that I put on one side of the graph, that's 2 units away. There's another point 2 units away. What's the ordered pair on that point, do you guys think? Negative 1, negative 5. Negative 1, negative 5. See, I'm not the only one who can make mistakes, right? So negative 1, negative 5, you see, you're starting to see that symmetry arise. We're getting the shape of a parabola. Okay? Now, there's also a quadratic pattern here. I want to talk about quadratics for a second. X squared is what we're calling a quadratic. If you take 1 and you square it, what do you get? If you take 2 and you square it, what do you get? If you take 3 and you square it, you get? If you take 4 and you square it, you get? If you take 5 and you square it, you get? Okay? So right here, we go over 1, up 1. Over 2, up 4. Over 3, up what? 9. So if I go from the vertex, if I go over 1, 2, 3, I have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a point 3 units away from the axis of symmetry here. There's another point 1, 2, 3, oops, 1, 1, 2, 3 units away on the other side. What are the coordinates of these points? 4, 0, and negative 2, 0. What do we call these points? If they're on the x-axis, they're called the X-intercepts. Okay, now we continue on. We went over from the vertex. I went over 4, up 16. There's another point. This one is 4 units away from the vertex. There's another point over here. 1, 2, 3, 4. What's that point? Right here. The ordered pair. This is actually 5, 7. Because you notice the vertex, the axis of symmetry is not on the y-axis. It's on the line. What's the name of this, the equation of this line, this axis of symmetry? The equation of the axis of symmetry is going to be this line right here, a vertical line, x equals 1. I'm just asking you for the equation of that actual line, which is x equals 1, right? Okay, identify the coefficients of a, b, and c. So remember we were talking about this ax squared plus bx plus c. Who can tell me what is a, the coefficient a? 1. What's the coefficient b? What's the coefficient c? Negative 8. Okay? What is the y-intercept of the function? We just graphed it. Yes, and I always like it as an ordered pair, 0, negative 8. If you say the y-intercept is negative 8, it's not wrong. It's just not as specific because what is negative 8? Y equals negative 8 is a whole entire horizontal line, right? This horizontal line right here is y equals negative 8. The point 0, negative 8 is 1 point on that line. Does that make sense? The difference? So my preference is if you're telling me a location, give me an ordered pair. How could you use the coefficients in part C to find the y-intercept? So we're coming up with a rule. How do you find the y-intercept in a quadratic? You already know in a line y equals mx plus b, 0b is the y-intercept. So what rule can you give me for a quadratic that's always going to give me the y-intercept? Zero C is the y-intercept, because whenever x equals 0, the only thing left is going to be C, right? Well, FOILed, yes, not factored. Yeah, if it was factored, you would just plug in x equals 0. So whenever x equals 0, y is the y-intercept. So 0c, just like y equals mx plus b, 0b is the y-intercept. That's for a linear equation, our first degree, right? First degree because it has an exponent of 1. For any second degree, whenever we plug in x equals 0, we're always going to get the y-intercept. Because all along the y-axis, what is x always equal to all along the y-axis? 0. X is equal to 0. Yeah? Questions so far? So what I want to show you right now is in Math 95 it is required for you to have a graphing calculator. Does anybody see what happened to my beautiful pink graphing calculator? Is it over there still? Oh, here it is. Okay, I want to show you that you can also, this table, this idea of a table of values is the same thing. It's the very first thing you learned when you graphed a line. Plug in x values, come up with y values, plot the points, right? That's always going to give you the shape of any kind of graph. But if you go to y equals on your calculator and you clear out what you have and you type in, you have to use this X button right here. So always use X, don't use your alpha lock. Okay, that's your variable X, that's an independent variable, X squared minus 2X minus 8. If I want to graph it, I press graph. And my window is set up all strange, and it's set up that way for a reason because we were graphing another kind of equation that required a graph, a window that looked like this. But if I just press zoom and I go standard, it's going to reset up the window to go 10 up, 10 over, 10 over, 10 over. And that's usually the viewing window. I mean, you can tell because of the graph we have here. This is a 10 by 10 by 10 by 10 or whatever. Okay, so there's our parabola. That's the exact same thing that we graphed. And by the way, you can always go to, if you don't have a graphing calculator and you're working on these problems at home, try them on desmos.com. This is a free online graphing tool. So you don't have to necessarily have a graphing calculator to do the graphing. And then if I want to find the table of values, so see how we plugged in all of these numbers here in order to plot the points? I can go second table, because that everything in my calculator in blue is controlled by the second key, and I can see they actually have a lot more points than I do. But there's the point 0, negative 8. Up here's the point negative 2, 0. Here's the point 4, 0. Okay, whenever y is 0, you notice where does that point live? On the x-axis. So the x-intercepts have the coordinate y equals 0, whereas the y-intercept has the coordinate always x equals 0. Okay, so let's move on. That's just basically how to use the calculator. I can always show you that in class too if you're stuck. A lot of times, most of the time when people aren't able to graph for whatever reason, it's like a really, really simple fix. It's like they have just some setting off on their calculator, so it's hard to show all of those possibilities on here. Okay, now we're going to show how to use factoring to find the x-intercepts. So remember that this f of x is really the same thing. is a replacement for y. It's just function notation for y. To solve, remember that we were always setting y equal to 0 in order to solve? This is what we were doing in the last chapter. We were setting y equal to 0. So to find the x-intercepts, we always need to first set y equal to 0, and then we're going to solve for x. Well, how do we solve for x here? By factoring. That's what we learned. We learned a whole chapter worth of factoring. I love it. So by factoring. 0 equals, what are the factors? X minus 4, x plus 2. Great. Any questions on how we got those factors? So what are the x values? Solve for x, please. X equals 4, because 4 minus 4 gives you 0, and you solve by setting it equal to 0, adding 4, right? X equals 4, so that's one solution. What would give you 0 over here? X would have to equal what to give you 0? -2. So that means the x-intercepts are, well, these are, we just solved for x. Right here it says write the x-intercepts as ordered pair. So remember, the x value goes first, that's 4, and -2. What was the y value? The y value was 0. Is everybody with me on where we got that? So your x-intercepts will always have y equal to 0. So this right here, you know, it doesn't actually matter what the equation is. And this is really important because in Math 95, you're going to look at different kinds of polynomials and different kinds of functions that aren't quadratics necessarily and aren't linear, but they're always going to have something in common. The x-intercepts are always going to have y equal to 0, and the y-intercept is always going to have x equal to 0. So it's kind of like people get confused by that, but you have a 50-50 chance, right? You only have 2 coordinates there. So whenever y equals 0, we're on the x-axis. So these are the x-intercepts. Okay, use the coefficients. Again, a equals 1, b equals -2, and c equals -8 to find the value of -b over 2a. -b is -2, because here's b, right? Over 2a. Who can tell me what's going to go in for 2? What's a? 1. So we get what's -2? +2 over 2 equals 1. Okay? Now it says, for the equation, find f of. This is the same thing as finding f of 1. Well, we just found 1. Actually, in essence, as x equals 1. So now I'm just going to plug in 1. So I have 1 squared, f of 1 equals 1 squared minus 2 times 1 minus 8. We did this math on the previous page, and I'm running out of room here, so I'm going to write it over here. 1 squared is 1, minus 2 minus 8. What's that? -9. Label the point. Now the point is 1, f of 1, which was -9, on the previous page. Well, we actually already have that point on the previous page. Here it is, 1, -9, which we called the vertex, right? The other two, there's the x-intercepts, there's the y-intercept, and there's the vertex. So what we're finding here is that for any kind of equation, you can always generate a table of values by plugging in x values and getting y values and plotting points all day. But what we're going to find is if we can find the vertex and the y-intercept and the x-intercepts, it gives us a pretty good picture of what the graph is going to look like. Especially because with the vertex, we have symmetry, okay? And that's really where this symmetry comes in. Okay, sketch your vertical line, x equals basically x equals 1, right? Because we already did this math on the previous page. The line, I already did this too. Here's the line, x equals 1, correct? This is a dotted line because it's not part of the graph, but it literally separates it in half. You know, you guys have symmetry if we were to cut you down the middle, right? You have 2 eyes, 2 nostrils. Okay, that's gross. But I'm saying the parabola, like you, has symmetry. Not all graphs have symmetry. A line does not have symmetry, right? And you'll come across other kinds of graphs. Right now, we really only know lines, and this one is parabolas. Okay, so some terminology. We've been talking about this all along. This point, this is the formula. For now, you're going to memorize it, okay? When you get to Math 95, it's going to come up again. You're going to actually go ahead and review all of this stuff in Math 95, but it's really good to learn it here first. Okay, so this is the vertex, and it will become more clear where this formula comes from in Math 95. I won't go into that now, but this point is called the vertex on a quadratic function. Okay, the line x equals negative b over 2a is the axis of symmetry. So essentially, you're thinking about it like this. Okay, if you have let's say you have a parabola, this one will open downward, let's say. Okay, this point right here is the vertex. It's an xy coordinate, right? But the line that goes through that point is x equals negative b over 2a. This x and y coordinate is the vertex. And then here, x equals negative b over 2a is just the line. Somewhere on that line, once you take the x value and you plug it in and find the y value, you get the ordered pair to show you where on that line the vertex is. You see what I'm saying? All other points are symmetrical around the vertex. So if this is 1 unit away, this is 1 unit away on the other side. If this is 2 units away, this is 2 units away on the other side. Same thing, 1, 2, 3, 1, 2, 3. So there's always going to be a point symmetrical. That's why I was able to, on the graph on the previous page, that's why I was able to, I only knew this point. But I said, well, if I count over 4 to the axis of symmetry, then it's 4 more units to the other side to give me another point. I never plugged in 5, but if you plug in 5, if we go f of 5 equals 5 squared minus 2 times 5 minus 8, I guarantee that will give you 7 if we did the math right. 25 minus 10 is 15. 15 minus 8 is 7. You see what I'm saying? Axis of symmetry is very helpful then in helping us determine the points and where this parabola is going to live on the graph. Okay, so this line right here, x equals negative b over 2a. For now, just put that in your notes and work on memorizing that formula. You're going to have more formulas to memorize in Math 95, but this is going to be helpful a lot with parabolas. Okay, so let's look at, 23 minutes. We're going to stop and start a new video.